that produce fractal systems
Mm-hmm.
in which infinities and finite systems are interacting together in a compatible way, where you need a boundary to define infinities, and you need infinities to define boundaries. And so the listeners could, if they have a pen and a piece of paper, they could doodle this. But I'm going to try to explain it without visuals, which is a little difficult. But
Sure.
if you make a circle on a piece of paper,
Right.
and you were to put a triangle in it, and then you put a reverse triangle, you have something like a star, a six-pointed star in a circle,
Right.
or like a Star of David in a circle.
Sure.
And so imagine that you went to each of the corner of that star and you made a smaller triangle. You could get smaller Stars of David to appear. And so you could make like little Stars of David inside that big Star of David, and each of these little stars would have a little boundary around it, a little circle around it.
Mm-hmm.
And then you could do smaller circles again on that smaller Star of David and get smaller Stars of David, and you could put a circle around that and get another boundary. Those would be resolutions in the structure of the fractal systems. Each one defines a scale. And you can continue to do that to infinity, meaning if you give that program to a computer, and you said to the computer every 5 iterations, zoom in to one of those boundaries, and then continue, and then zoom in again, and then continue, and zoom in and continue. The computer could continue to do this to infinity. Yet, you would never, ever, ever, ever exceed the first boundary that you've made for yourself.
Mm-hmm. Right.
The first circles you've made. So, within the confine of a circle, which could be a sphere, you could do it with a sphere and tetrahedrons.
Yeah.
You can put infinite amount of divisions. You can put infinite amount of information within what seems to be a finite space.
So this is it a little bit similar to like the Mandelbrot set that you can just go into it and into it and into it?
Yes, absolutely. And the geometry of it and how it divides, it's seemed to be intuitively correct at first. And the reason is because when you look at nature seems to do things that way. If you look at the branches of a tree, if you look at the way flowers emerge, it seems that fractal systems are found in nature everywhere.
Mm-hmm.
And so, to me, that was a very important clue, that nature probably uses some of these fractal concepts to produce creation. But what intrigued me was, where would that be? Meaning, where is the geometry coming from?
Right.
Like how... Go ahead.
Oh, no, I just said right, so please go ahead.
Yeah. How does it emerge? And, where is it coming from? And so that took me longer. I had to start studying a lot of physics and all this. And eventually, I realized that when we think of reality, we think of reality as what's there. Like, for instance, a tree, a plant, a house, a phone, a wallet, whatever is around,
Yeah.
you say, oh, that is there.
Yeah.
That is real. However, for instance, we know that there's all sorts of electromagnetic fields and all this that you don't see, but or you don't experience directly, but that doesn't mean they're not real. For instance, we know that if they're strong enough, they can do all sorts of real things, including carrying information across long distances, radios, televisions, and all this.
Yeah.
So there's an unseen reality that has real physical effects as well. Well, I started to realize as I studied physics that there may be another level of unseen reality that we don't directly experience. And that reality, that level of energy and structure would be what is called the vacuum, meaning that we think of what's between things as emptiness, but there's not really any reason to think of it that way, that we could just as well think of what's in between things as fullness. And that the things we call reality just emerge from the vacuum and returns to the vacuum, emerge from that fullness and returns to that fullness. And maybe if I can give you a visual, you could think of water in a pool. And if I pushed a plate in the water in the pool, I would make two little vortices on each side, two little vortex, two little swirls. And they would be spinning in opposite direction. And if, I could say, oh, there's a swirl, but the swirl is just a dynamic in the water of the pool. And if I didn't know that the water of the pool was there, and I could only see the dynamic, I would only think that that's the only thing that exists. I wouldn't know about the water.
Right.
And why would I miss the water? Well, how would we miss the fullness of space? Well, because space is everywhere. The atom is made out of 99.99999% space.
Yeah.
And so what we call reality is a little bit of a jiggle in the space. And we call that an atom. And we call that reality. And we say, oh, there it is. But it could be just the dynamic of the space itself.
So what you're saying here is that the physical reality is an effect of something that is occurring in the vacuum.
Exactly. And that it emerges from the vacuum and returns to the vacuum.
Right.
Let's go back to our plate example in the pool. If you push a plate in the pool, you'll get two little vortices on each side. Now, if you look under the water, you'll find that the two vortices are connected by a string of air under the water. If you put your hand between that string of air, the vortices will disappear. And you'll think that the energy is gone, that the dynamics is gone. But if you take your hand out again, then they can reappear. And so what I'm saying is that I believe that, and the physics I've written supports that actually reality is blinking in and out of the vacuum at a very high rate.
Right.
And just like a movie, which appears continuous when it's run at the right speed, but if you look at the movie itself, at the film, you can see it's a piece of, it's an image with a space, with an image, with a space, with an image, with a space. And when you run it fast enough, it appears continuous. I believe that matter, and we know, for instance, that the electron and the positron exchange across the, blink in and out. That matter is blinking in and out at an extremely high rate into the vacuum and out of the vacuum and into the vacuum and out of the vacuum. And because the vacuum is everywhere, when it blinks in, it informs the vacuum, and when it blinks out, it experiences the world. And then blinks it, and then it blinks in the vacuum again and informs the vacuum, and then blinks out again. And so the vacuum is constantly informed of everything that's going on.
Very interesting.
And go ahead.
Oh, yeah, I just said very interesting. I mean, that would suggest that it's a cycle rate or a specific frequency going on here then. Is that correct?
Yes, and that the cycle is at the speed of light.
Speed of light, okay.
Yes, and that's why we experience it as a limit. And that this cycle rate, this very high rate of information transfer, is self-organizing all things. That because the vacuum is everywhere, and as soon as it receives information, it knows what's going on, it self-organizes in a very rapid way, and that explains many things in physics that are unexplained. For instance, how is it that our planet produced so high level of complexity so rapidly since the Big Bang? You know, people may think 14 billion years is a long time, you know, but when we look at our planet, it's much shorter than 14 billion years, and we have, you know, extreme complexity in biology that is available to us everywhere. And in order, if we did mathematical analysis of that, you know, just by random function, the probability of all this coming together in such a wonderful, organized way is extremely low.
Right.
In fact, you know, it's impossible. And, you know, even for just one blade of grass to come together with all the complexity that's involved in it, it would take more than 14 billion years for that to happen, just by random function.
Right.
And so the tendency when we say that is for the religious people to say, oh, but, well, it's God that organized it all.
Sure.
And what I'm proposing is that, no, there's just a feedback dynamic in space-time that produce self-organizing systems. And that feedback, you know, is what puts everything together and takes everything apart. And when you know, and when it self-organizes, it goes towards higher and higher levels of complexity very rapidly, because it knows what everything is doing. So it knows what works and what doesn't work.
So when you say that, that suggests that it might have started out very chaotic then, and it's moving towards a higher degree of order. Is that right?
Yes, that it always moves towards higher degrees of orders and higher degrees of complexity, which, you know, may seem to contradict the laws of thermodynamics, which says that things always go towards disorder.
Yeah.
But this is what the conflict is in physics, is that our law says that everything goes towards more disorder. So since the Big Bang, things should have decayed. But when we look at our planet, we can see that things have gone towards higher and higher levels of complexity and order. Let me give you an example. For instance, in a human being, if I took all the DNA that's inside a human being and put it end to end, you could grab that DNA and wrap it around the world 5 million times. So this is how much DNA that's inside a human being, completely self-organizing. There's about 100 trillion cells in the human body, completely, you know, communicating across, you know, large distances relative to a cell, you know, between your toes and your hairs. And everything is making sure that everything's functioning properly, that your toe cells don't start making nose cells, and your nose cells are not making toe cells, and, you know, everything is communicating and highly organized.
Sure.
And so what I'm saying is that there is an underlying organization, there's an underlying structure in the vacuum itself. And when we look in quantum theory, in order for all of our physics to work in quantum theory, there is a very important part that's not talked about much, and that is that the vacuum cannot be empty. The vacuum inside atom has to be fluctuating